For chapter 10, here are the two concepts that you need to be familiar with. The hypothesis test for two population means for independent samples and paired samples. And then for chapter 14, you need to be able to be familiar with how to run the linear regression tool in Excel, and then run the hypothesis test for the significance of the slope coefficient. So let's run through a hypothesis test for two population means for independent samples. Suppose a job placement firm wants to know if the 2017 starting salary for accounting majors is higher than the starting salary for finance majors. What is the alternative hypothesis being tested? So we could formulate our hypotheses is that the population mean for accounting majors is less than or equal to the population mean for finance majors. Remember the equality sign, which will always be in your null hypothesis. And then our alternative hypothesis is that the population mean for accounting majors is greater than finance. So in the story, it says accounting majors is higher than the starting salary for finance majors. So that's going to be your alternative hypothesis. Calculate the degrees of freedom. So when we're dealing with two population means, the degrees of freedom is going to be -2. So in this case, the sample size is 110 and 124, and then we're going to subtract 2. You need to determine the type of test. The reason why this is important is because you need to know what type of test you're working with. So when you're reviewing the t-test output, you will refer to the correct numbers. So we know that this is pointing to the right. So this is going to be an upper tail test. So on the exam for both of the chapter 10 hypothesis tests for independent samples and paired samples, you don't need to run the test in Excel yourself. So I will give you the output, and then you just need to make sure that you are referring to the correct values. So let's go ahead and review the t-test Excel results for this data. So this is the output that you get. And so we need to identify the appropriate critical value and test statistic for an upper tail test. So the critical value, we're going to come down here to get the t critical value for a one-tailed test. And that's going to be 1.6514. And then our t-test statistic, or our t-stat, as it's abbreviated in the output, is 4.0871. So since the t-test statistic is greater than the critical value of 1.6514, this is in our rejection region, and we reject the null, and we do conclude that the mean for accounting majors is higher than finance majors. Let's run through an example for a hypothesis test for two population means for paired samples. To increase productivity, Jamba Juice employees went through a smoothie making training program. To test whether the program was effective, a sample of 7 workers was taken, with each worker's productivity recorded before and after. So we know we're dealing with paired samples because we have the sample of workers is the same, and it's before and after some event. In this case, the event is a training program. Jamba Juice is interested in determining whether the training program helps employees make more smoothies per day on average. So based on the t-test results for the 7 Jamba Juice employees' productivity at the significance level of 0.05, can we conclude that this training program was effective? So here in the problem, it told us that this time we're going to use the p-value approach. So that's important because we want to refer to the correct values in the output. But first, let's formulate our hypotheses. So in this case, we're looking for the verbiage in the story, and we want to know if the training program is helping the employees make more smoothies in the day. So is the population mean after the training program, is it greater than the mean before? And the null hypothesis is that it's less than or equal to before. So there's no improvement, or it got worse. With paired samples, you could also frame your hypothesis statements in a simpler way, and we could just say that the difference in the two means is less than or equal to 0, and then alternative hypothesis is that the difference of the population mean is greater than 0. So if we take the population mean after the program and subtract the before, it would be positive, or it went up, it got higher. So just recognize the two ways to formulate our hypotheses when you're dealing with the paired samples. So what type of test is this? This is going to be an upper tail test. We know our alternative is pointing to the right. Similar with the independent samples, the paired sample, the t-test results will be given to you. So here is that output for after and before. And so we need to identify the appropriate p-value. So here we know this is an upper tail test. So we're going to go to the line that has the p-value for a one tail of 0.027. And since the p-value is less than the alpha of 0.05, we are going to reject the null. And we can conclude that the training program is effective in making employees make more smoothies per day. All right, let's go ahead and wrap up this review and go through simple linear regression. On the exam, you will need to be able to run regression in Excel. And then there will be some fill in the blank style of questions where you take the output and you will fill in parts of the answers. We'll do that in a moment here. So the marketing director at Macy's is interested in analyzing the relationship between the company's weekly sales and the advertising dollars spent. The director believes that advertising dollars spent can be used to predict the weekly sales. So they did a random sample of 20 weeks. They collected and recorded the sales for each of the week and the amount spent on advertising. We're going to use the Excel file provided. So I do provide the Excel file for the study guide as well as for the actual exam. So you're going to use that data and you're going to run the regression and you're going to fill in the blanks. Then you're going to also have some questions that you need to answer from the output. And we're going to be using an alpha of 0.05. First, let's identify the key variables. So we know that our dependent variable in this problem is going to be weekly sales. And we are using our advertising dollar spent to help predict our weekly sales. So step 2 is to run the regression in Excel. So let's go ahead and do that now. So to run your regression, you're going to click on the data tab and you're going to go to the far right and you're going to open up the data analysis toolpack. You're going to scroll down to find the regression option and you click OK. If you were practicing on the before the exam, like with the guide, it will remember the last thing you did. So always double check your inputs. So our y is our dependent variable. So we know that our dependent variable is going to be our weekly sales. I'm just going to do it again just to be certain. So it's A1 to A21. And then our independent variable is our advertising spend. So that's going to be B1 to B21. Always make sure that you include your header or your labels. So in row 1, it says weekly sales and advertising, and then we're going to check this box. If you don't check the labels box, you're going to get the error because it's going to try to run regression on text, and that doesn't work. In our problem, it was an alpha of 0.05. So we know that with our level of significance of being 0.05, that is a 95% confidence. The linear regression tool will always give you your confidence interval estimate for the slope coefficient. But if you needed to change it to get an additional output, you would check this box and you would type in your confidence level. So depending on the problem, you may or may not need to do this. I'm going to leave it unchecked because we're interested in the 95% confidence. And for here, I'm going to go ahead and just put it on E1. And I'm just going to click OK. So let's go back to my slides. So once you get your output in Excel, you need to fill in the blanks. So I've simulated that here on PowerPoint. So the first number that we're looking for is our SSR. So this is our sum of regression. And so you would just plug in 314,258,43.57. The next fill in the blank that it's looking for is our t-test statistic for our slope coefficient. So our t-stat is 9.54. And then our lower and upper 95% confidence interval estimate for the slope coefficient. So our lower is 7.57, and then our upper is 11.84. Step 3 is to define the linear regression model. So we got our y hat, our predicted weekly sales, is going to be our intercept, so b sub 0, plus our slope coefficient, or b sub 1, times our x, our independent variable. So if we just plug in the numbers from the output, we have 460.57 for our intercept, and then we have 9.70 for our slope coefficient for advertising, and then we have our x. This is our linear regression equation. Step 4 is we need to identify our coefficient of determination, or r squared. So you'll use, just for simple linear regression, you would just refer to the first r squared here, or 0.8349. The way we interpret r squared is 83.49% of the variation in weekly sales is explained by this regression model. And the next step, let's go ahead and plug in our $500 for our advertising spend to calculate our predicted weekly sales. So we're going to take the intercept of $460.57 plus 970 times the $500 for x. So you plug in $500 for your x variable, and we get a predicted weekly sales of $5,310.57. So the last problem is, now we're ready to test for the significance of the slope coefficient. So to test to determine whether this regression slope coefficient is significantly different from 0, we're going to use an alpha of 0.05. The t critical value is given to us in this problem at 2.10. Using the t-test statistic from the regression analysis, what is your conclusion regarding the regression slope coefficient? So for here, we only need to identify the t-test statistic in our regression output. So you don't need to calculate this. And so we know that this is our t-test stat of 9.54. The t critical value is given to us in the problem is 2.10. So based on the critical value approach, since 9.54 is greater than the 2.10, we do reject the null, and we conclude that the advertising spend is a significant variable in explaining the variation in weekly sales.